The main topic, modular architecture, we have at the very top level features. So a feature can be a search screen, a favorites, and on the lower level, we have the core stuff. A modular architecture promotes portability and composition, facilitates reusability, and make it easier to divide work. Also, it should be flexible, it should be comprehensible to reduce cognitive load. Basically, what this means is that we don't want developers to have to understand a lot of code to work in some small stuff. So if you make your architecture modular, I just have to understand this small part of the project instead of understanding everything. At the end of the day, for us, it improved a lot of the velocity we had thanks to tools like SPM and others that I will mention later on. Things to consider for day one. This is very important. So thank you everyone for joining here today. I'm LIBRANNER SANTOS, and I'm going to be talking about modular architecture. This is a tale about modular architecture, so it's about the principles, tips and tricks and things we have found out during the last 2 years or so working with a modular architecture that heavily use stuff like SPM, SwiftUI, and the latest Apple stuff. As probably you know by now, I'm LIBRANNER SANTOS. I've been working with software for about 15 years now. I work mostly with Swift, but I also have some experience with Flutter, C#, Ruby on Rails, and other technologies. I also contributed to some books on auto layout by tutorials, which sadly was published the same year SwiftUI came out, so as you think. But it was a nice experience, and I think a lot of people enjoy it. I also work in the SwiftUI Apprentice and the Real World iOS by Tutorials that were published by Ray Wenderlich at the time, which now is Coreco. And on my spare time, I'm a writer, a blog called Async Learn with some friends. And I work as a domain architect for Kindred Group, which basically means I try to overcomplicate stuff for developers on my daily basis. So yeah, what we'll be covering here today is how we came up with this modular architecture that works pretty well for us and that the developer feels comfortable working with. Because for me, architecture is not only solid principles and separation and concerns and stuff like that. It is about developers being working at their best. We care a lot about velocity, testability and stuff like that. So I will be covering some concepts that help us with that. In our initial effort, probably you are not able to see this image, but give me a second. This is what we decided to go with. We were only 3 developers on the team. Let's say at the first stage, it was more like a proof of concept. We had to demonstrate that tools like SPM, SwiftUI will help us achieve our goals. So we decided, okay, we will divide stuff in 2 teams. At the time, it was just 1 developer per team. Create a repo, and we will create something called modular monolithics. So basically what this is that you have your foundations that can be your models and stuff, and also inside of every Swift package that was inside a repo, we have something called providers. In our architecture, this can be a repository or something like that. And also, we decide to abstract users of these packages from anything related to user interface creation. This makes sense for our product because we wanted to provide our users, which is our internal users, complete implementations of screens. So we don't want them to care about how these screens are created. We want to use SwiftUI and provide factories so you can create whatever screen you need. This was nice, and this concept of modern monolithics, we still have it, but we realized that we made some questionable decisions along the way. Modular monolithics allow us to work as independent units. You also reduce the number of deployment targets or things that you have to bundle and deploy. So this can help velocity. And this is a close shot or what the most important part of this modular monolithics looks. So you have your models, you have your factories, so you can expose UI elements. But we realized that there was stuff missing. First, we want to make sure that we have testability reusability. So people, if you have a button that's pretty much the same across all the app, we want to have a place when you can just take that button and use it. We also have an improved visibility. As I said, we were a total of 3 developers. So if you have like 3 repos or 4 or 5, it will be very cumbersome to try to review these PRs and have a nice velocity. We wanted to improve collaboration. So even though there were separate teams, there were stuff that are common for both, and things like standardization and velocity that I think I mentioned a few times now. So for visibility, we tackled 2 principles, which are centralization and synchronization. Centralization basically means, hey, we want to be able to see everybody's code, but we want to keep the separation of concerns. And for synchronization, the solution for us is that we use trunk-based development. So basically, everything that you work on that is merged, you have to create your PR, obviously, be reviewed by the team members, but once it's merged, it's ready for production. So about standardization, we wanted to have a set of tool chains that allow us to improve our velocity, but that governs how engineers interact with the code, including building, testing, browsing, and reviewing code. So our answer for all these necessities, and probably people can be not okay with this, is to use a monorepo. So basically, a monorepo allows us to have all this visibility, centralization, standardization very easily. And the main reason is that developers can see other people's code, and thanks to SPM and some stuff we're going to mention later on, you still have your separation of concerns. So basically, if you have a big Swift package with a bunch of products, unless you make some stuff in there public, you still have completely separated from all the other modules. Lessons learned to, you should consider a caching strategy early on. When you start using external dependencies, like say you are using Facebook for analytics. This can add a significant amount of time, especially on fresh builds. Over engineering, as I mentioned at the beginning with the modular and monolithics, we have one provider for module. We realized that for our project, the provider will be the same for all the different modules. So what we did is that we promoted the code to be one provider for everyone. And this introduces a concept called shared packages that we're going to talk later on. The monorepo, it has been proved to be a great solution for us. We don't have to care a lot about versioning, but you have to be careful with some stuff that comes with the monorepo, some limitations. So be careful with the Git history. This is a real life example. We have one project when for some reason, this was like 7 years ago, some developers introduced very big files, like gigabyte of files. And we still have that in the Git history. So when you put that into the monorepo and you try to merge everything together, every time you do a clean and try to get the dependencies for a Swift package, you're going to have to wait a significant amount of time. So be careful with that if you're going to kick with a monorepo. As I say, not able to have an independent versioning, this is not a problem for us in the nature of the project we're working on, but keep that in mind. If you start putting everything into a monorepo, you won't have this independent versioning going on for your module. Compilation time. To be honest, for us, this is not a big problem yet, but along this talk, we're going to talk about some things you can do, some techniques you can do to try to avoid issues with compilation time. So the main stuff in this story of modular architecture is using Swift Package Manager. As probably some of you know, or most of you know, Swift Package Manager manages the distribution of the code, the load, compiles, and link dependencies, and it's a tool provided by Apple. So even though we use CocoaPods and for some projects Carthage a few years ago, we decided to go all in with Swift Package Manager. We understand that it's something provided by Apple. It works very well for us. It allows fast development, and to be honest, we don't have many issues with Swift Package Manager from the day one. A package, which is the smaller unit contained by the Swift Package Manager, contains the source files and the manifest files, where you define your dependencies, you can define your resources and the way they are treated. And one important concept that I wanted to focus on is the fact that of products. The first thing I want to say is that even though you have a Swift package manager, not everything that is inside that package has to be exposed. So if you decide that you have some code that is just responsibility of that package and doesn't have to be public, you can just not export it as a product, and you can still have a nice encapsulation. We encourage teams to have these big packages with a lot of modules, and the fact that they can use shared models to practically. So for example, one clear example of a shared model is our UI design system. So we want people to use the same styles, we don't want people to use the same buttons, so that's a shared model. And in the same Swift Package Manager, you have a bunch of feature models. So a few lessons that we learned about Swift Package Manager. You have the ability to have modules very well encapsulated. Swift Package embrace convention over configuration. Probably some of you have seen that if you go and create a folder in a package and you don't put it on the manifest file, you can get an error. So what this is telling you is that you don't need to go and configure this separately. Swift Package Manager detects that is changed in your directory, and it tries to generate code for you. Make it easier for us to face the multi-product scenario. This is also called, in other companies, white labeling. So basically, since we use Swift Package Manager and we manage the concept of modules, we can just take one of those modules and use it in a completely separated app. Other lessons is that we are trying to use SPM plugins to automate some boring tasks. So be aware that if you're using pre-built plugins, it shouldn't last long. It affects compilation time, and it can turn into a very big problem if you rely on them. As I mentioned, you can make package private, but not exposing them in the manifest. And one thing that we face is that developers were trying to do some very complicated configuration models. So basically, your package should receive a very dumb struct with the configuration options you want to pass down. In our case, this is very important because, for example, if you want to use Firebase to provide all your configuration stuff, or you want to do some A/B testing using Growthbook or Optimizely, at the end, we want this to be very plain struct objects, very simple. So as a rule, every package should get this configuration in a very simple form. And at the highest level, which in case can be the app level, we decide what to use. If we want to use Firebase, if you want to use Optimizely, or whatever other tool. Other lessons we learned is that package results should be tracked in Git. What this guarantees is that all the developers in your team are using the same version. Always put support files in resource folders. You can call it whatever name you want. We use resource as a standard. And be aware, and this is something we were experienced some time ago, not so long ago. For some reason, a developer on a third-party company was using copy when they were adding resources to SPM. And what this caused is that basically Xcode add that file to the bundle exactly as it is. So if you have something, I don't know, but for example, files like zip files, JSON files, images, Xcode comes with some stuff that basically compress those files for you and then optimize it. If you use copy, none of that happens. So by the rule, we should use process. And if Xcode detects they cannot optimize the file, they will use copy as a fallback. So basically, try to always use process unless you're very clear that you want to use copy. And also, a nice standard we introduced is use exclude folders. Basically, developers can feel the need to just put everything in the resource folder. But if you have some files that are just used for, I don't know, upset testing or something like that, and you don't want to include it in the final bundle, you can use exclude folder and exclude it from your SPM package. By the way, it's not just adding a folder called exclude. You have to go to your package manifest and include that you want to exclude that. It's just one line of code. And also a use case that we face, we wanted to point to master directly, and what was happening is that at that time, Xcode wasn't smart enough to basically detect that something changed in master. So what we developed is a small script that basically looks for the latest commit and change the SHA commit. So basically, every time you run the script, you get the latest version. Probably this is not necessary anymore, but at the beginning, and I'm talking about Xcode 14 dot something, it wasn't happening for us with this code. So the main topic, modular architecture, this is what we were looking for, and pretty much what we got. We have at the very top level features, so a feature can be a search screen, a favorites, landing page, and on the lower level, we have the core stuff. So we have analytics, we have login, we have localizations, and if you keep going down, you will find stuff like networking that contains like socket communication, HTTP related stuff, reachability. And one very important topic that we will keep mentioning during this talk is navigation. So apart from that, we have some UI stuff, we have a design system, and at the very bottom, we have some foundation models that are shared between all these packages. A modular architecture promotes portability and composition, facilitates reusability, and make it easier to divide work. Also, it should be flexible. So for example, if one module changes drastically, if it doesn't change any public protocols, it shouldn't affect, or modules, it shouldn't affect any other packages. It should be comprehensible to reduce cognitive load. Basically what this means is that we don't want developers to have to understand a lot of code to work in some small stuff. So if you make your architecture modular, I just have to understand this small part of the project instead of understanding everything. At the end of the day, for us, it improved a lot of the velocity we had thanks to tools like SPM and others that I will mention later on. Things to consider for day one. This is very important, and it doesn't matter if you decide to use MVVM, TCA, or any other solution or architecture. Navigation. Especially, I don't know if you have the luxury of support iOS 17 only, but in the company I work for, we have to support at least 2 versions older. So right now we are supporting iOS 15. So with iOS 15, you have the navigation view, but with 16, you got the navigation stack, which is a very nice improvement. So from the very beginning of your project, doesn't matter what you're using, you should consider how the user is going to navigate, how you can cover stuff like deep linking, and so on. For example, we had an issue with iOS 15 when for some reason the pub to root doesn't work properly, and if you add elements into the navigation bar, the swipe doesn't work. So all that stuff, you need to have a solution in mind. For us, we created a small library, and I'm going to show you a design in just a moment, that allows us to do that. But with iOS 16, you will get more improvement. Also, there is a talk, I think it's tomorrow, about navigation, so I encourage you to watch that. Another thing you have to consider is a nice UI design system. Developers sometimes can feel the need to, for example, if you're working on a button that is green, to just create a complete implementation. So everybody has the green button. But what happens if UX comes tomorrow and tell you, no, I want the button to be blue? You have to go and change that implementation. But then the day after, they come and say, no, I want a primary button that is green, and I want a secondary button that is yellow. This is stuff that happens all the time. So if you have a nice design system that uses, and this is a very basic principle, you should try always to start with a style. So for example, if you are working with a button, you should start with a button style and create as many styles as you need. This promotes composition. So for example, now instead of going to the actual implementation and changing something, you can just say with a modifier, I want to use the button style primary, and that should work. Your testing approach, this is something you have to consider very early on, and it can decide and can influence even what architecture are you going to use. For those that prefer TCA, it is a very nice solution. It has exhaustive testing and a lot of other stuff. Spoiler alert, we didn't use TCA, and I'm gonna tell you in just a moment why. Supporting tools. So this is something that, as part of the architecture we want to cover, we want to make developer experience very easy, and we're gonna improve velocity all the time. So you should identify, and I'm gonna talk about a few later on, the tools that promote visibility and that allow developers to do their best job. So The unit of modular architecture is modules, which is a reusable set of functionalities, can interact with other modules through known interfaces. And this is very important. A module should never depend, a feature module, directly in another feature module. If you find yourself doing that, you are adding a strong dependency, and next time a team is doing something with a module you are not working with, you will be affected by that. So you should try to promote principles like dependency inversion or dependency injection in some cases, but mostly dependency inversion, to try to make developers work on public APIs, and other developers should only be affected if these public APIs change. We realized in SPM, as I've been saying, to create these modules. And there are two basic types of modules that we use, which are share modules that contain stuff that have been used by 2 or more feature modules, and feature modules, which is where we include the concept of modular monolithics. This is how a feature module looks. In our case, this is some libraries that we have as part of the company, like Kindred Networking, Kindred Foundation, that contains stuff that pretty much all our apps uses. But the modules is located right here, and it uses this dependency to public APIs, and it doesn't depend directly on those, even though sometimes it's very hard to do this. You should ask those libraries to inject whatever you need from them. For our feature packages, we use MVVM, and we use the concept of provider. So basically, you have your ViewModel when you have all the business logic for that view. You have your model, which for us is very basic and dumb structs. And you have a provider, which basically is your connection with HTTP servers and stuff like that. So principle for introducing new code, we use the concept of promoting code. So basically, every time you introduce new code, even though you think this can be used by other people, we tell developers that this should be have the higher access modifier. So for example, be internal at first, and then if it's necessary, we promote it. Business logic goes mostly in the provider. It has to be reused by different modules, but some business logic also goes into the view model. Keep views small and composable. So this is something that probably all of us have heard a lot about using SwiftUI. And as I mentioned at the beginning, I have some experience with Flutter. And if you try to understand how SwiftUI render your views, there's something called identity, right? So depending on that identity, it decides if it has to re-render the tree. So if you use smaller views, you're giving the best way for SwiftUI to have some nice identity to your views. So what I recommend, instead of just creating a bunch of functions that return some view, if you try to use smaller views and you use the actual name of that view, you're trying to help SwiftUI to identify it. So this is something that I think it hasn't been proved using actual testing and performance. But as I said, I come from Flutter and other declarative UI solutions, and this is the way it is recommended to do. Depend on abstractions, not implementations, and this goes hand in hand with a dependency inversion principle, and we're going to see something about that just now. So this is one thing you can do. So you have a feature model that is called landing, and it needs a provider. So basically, what you said is like, I'm going to depend on the provider interface. So now I don't have a direct dependency on the provider implementation. I don't care how it's implemented, but I'm using this interface. This is good, and probably most of the time this is what you need. But what happens if in that share module, that right now is a provider, you start having a lot of protocols, a lot of business logic, and the implementation gets to be really big. And for some reason, you are not able to divide it. What can happen is that you can affect compilation time. So right now, even though you are depending on that interface, every time you compile, SwiftUI has to compile both packages. I know that there's some caching going on, so not all the time is a fresh, but you can start having issues if you have like really big packages. So one thing you can do is that you extract that provided interface or protocol and put it on a separate package. Now, both packages depend on that one, and every time you, for example, have to compile landing, you just have to compile the protocols. So this can improve a lot the compilation time. Again, this is probably not something that I do from the very beginning, but if you start having problems with your compilation time and you measure using whatever tool, Xmetrics or something like that, and you start seeing increases on compilation time, this is one technique you can consider. So for a feature package, we develop a document to provide the developers when we make a list of the stuff we consider a good feature package has. First, it can be tested in isolation. He has his own catalog that provides visibility, and we're going to see an example later on. All logic, especially public APIs, is unit tested. Configuration can be done with using plain objects. It doesn't depend on another feature package, and again, you can use dependency inversion and dependency injection to help you with this. And again, it uses dependency injection, and we're gonna see a small example of how you can provide your users with a very easy way to inject the dependencies, to register these dependencies at the very beginning, so you can provide code that is not coupled with other features or other people's code. I'm going to talk a little bit about MVVM. It allows us to separate the view from the application logic. We are able to test the business logic without even rendering a view. And it was probably the easier solution we found out when we started this project. Why we choose MVVM? We have a huge code base that already uses a nice dependency injection tool, and we don't want to switch it to use environment object. This doesn't tell you that you have to necessarily choose between one or the other. You can still use both, but it can add some, some ambiguity from developers. Should I use environment object or should I use dependency injection? In our case, at that time, we were using Resolver. So we said, no, we want to keep the way we do it now. Also, we evaluate some solutions that focus on being completely SwiftUI. We, at the moment, cannot afford making that risk because we also have a lot of code that was using UIKit. And I know you can use hosting view and UI view representable to do this communication, but this can add a lot of boilerplate, and we just don't want to risk it at the moment. And low testability, other solutions like MV try to tell you that it's a good idea to not test the view at all, and we don't like much that approach. We wanted to be able to fully test our business logic and also our views. And this was another big issue, is that we started with a very small team, and the learning curve for some solutions that we evaluate was significantly big. So we didn't want to invest a lot of time, and we didn't have a lot of time at the moment. But a nice thing about using modular architecture is that if you have a future model that for some reason other teams want to use a different approach, they want to use Redux instead of MVVM, they can still do it. This is something that probably none of you can see, but I'm going to explain right now. This is a diagram we created because one issue we have all types of developers. We have junior, senior, staff. So for some reason, some developers decide that every time they create a SwiftUI view, they will create a ViewModel. And that's not exactly true. There are some cases when you can just pass something in the initializer. There are some cases when everything can be private. So we developed this small diagram that basically asks you some questions and tells you if a ViewModel is enough, if you can just use a model, or you can just pass it in the initializer. What it says here is that first look at your view, ask if you just have private state. In that case, you don't need a ViewModel. Then you ask, do you really have some complex logic going on? Or do you have to pass something that is only used during initialization? Then you can just pass it in the initializer. If you still have a lot of logic and you consider you have to test it, This logic access external services like a provider or HTTP server socket. Then you should use a ViewModel and so on. So basically, these are very basic questions, and every time a developer is not sure what to use, they can go to this diagram. Again, I'm going to share the presentation. If you're interested, you can actually see it there. So pain points. Sadly, with every decision you made, there are pain points. There's no silver bullet. With MVVM, one we faced at the very beginning was state object versus observe object. When you use one or the other, you can have unexpected behaviors in your views. So if you use observe object and the parent view for some reason has to change state, the child view, if it's using observe object, will be re-rendered. So we face that and we say, oh, we have to use a state object. But then we realized that per Apple documentation, even though it's a little bit ambiguous, they tell you not to initialize a state object. You have to pretty much provide the instantiation at the moment of you instance your view. You cannot just go in the state and say init, state object, blah, blah, blah. But then we got soft endorsement from Apple during, I think it was WWDC 22 or 23. And said, well, okay, we can use this. Fighting the framework, you will feel like that. One clear example is environment object. If you want to manage your dependencies with a different way, you will feel like, well, I already have this. Why I have to implement a different solution? Another clear example is that it feels like Apple is pushing more for NB because if you're using core data or Swift data, they provide you with these nice property wrappers that go into the view. But I feel like you are trying to, it's that decision you have to make. You want to rely on that and just pretty much make it really hard to test stuff. Or you can provide your own solutions. That's not something that the team has to decide. Testing views is not necessarily easy in SwiftUI. There are two approaches we consider, and I'm going to mention that just now. So for us, it was between view inspector and snapshot testing. View inspector was the solution we chose at the end. It's faster for us. It has this feeling of your unit testing your views, and it is a concept I don't fully agree with because developers usually try to do a lot to test the view, and it feels more like a BDD than actually unit testing just a small part. But we decided to go with the view inspector also because we had some experience with the snapshot testing, and we have some very weird issues with flaky tests and test breaking. And one thing that used to happen every now and then is that for some reason a test wasn't passing and was breaking a lot of other tests because it was a reusable UI element. So a developer can just go and generate all new screenshots, all tests will pass, but you don't even check what was wrong. So that was something that happened more than once. And obviously we check it on the PR and say, no, this is wrong, you have to, but we decided not to go with the snapshot testing. Dependency injection makes it really easy to write UI tests. If you write performance tests, we try to do that for some use cases, you'll find it very hard to do it without using XCT UI tests. If you use dependency injection from the very beginning, you can inject whatever amount of data we want to use for your performance test, and you create a performance test for memory or whatever you want to do. Just one side note, for performance tests, obviously it's better on a real device, and for us we use a provider called Browser Stack, which is basically a farm of devices, and we just provide the UI test, the project, and they run it and they give you reports and everything. So having ViewModels allow us to test the business logic easily, and at the for testing, there's one that is really key. If you're using SwiftUI, Swift data, something like that, which is battery. You should test your apps, and the older, in our case, was iPhone 8, I think, the oldest device you support. And we found that, for example, this is a real-life scenario, we were getting a lot of notifications from a socket communication. So you have to change the view constantly, like every few seconds, sometimes less than that, I think. And basically, we just create a solution, we put it, it works, it looks fine in the simulator. But when we started doing performance test profiling and check the battery, we were draining the battery really fast. So basically, if you just test it on the simulator, you don't pay attention to the battery. Since SwiftUI is kind of a black box and is doing a lot of re-rendering for you, you won't be able to identify these kind of issues. So definitely battery. Others that are more common like memory and CPU, you should take a look. And also launch time. Since SPM decides, unless you provide it, if it's going to do a static or dynamic linking, this can affect launch time. So if he just goes and put everything dynamic, you'll have a slower launch time. So what I suggest for this is at least create a performance test for your launch time in an old device you support, and then you can have some kind of regression going on and identify if you really have to go to SPN and indicate, no, for this, I want you to use static linking, for example. Navigation, this is not necessarily easy with SwiftUI, and there are two types, which is global. Basically, one feature can navigate to another, and local, which is one feature can have their own private navigation. For this, since we have to support iOS 15 and we cannot use navigation stack, we created a library that basically does what navigation stack do. We have this nice modifier here called navigate. You declare a state called route, and every time that route changes, I just navigate to whatever that route is. The implementation looks more or less like this. You have a navigation coordinator that has all the builders, and it knows how to build the destination view. And you have a set of routes that conform to a protocol that has a method called makeView. So every time a navigation detects this change, it can just look for the destination and provide it to you. Another thing that allows us to do is that for some reason, when you have like a UIKit SwiftUI project, sometimes if you add an element to the navigation bar, you lose the ability to do swipe to pop. So these allow us to implement that easily, very easily. And yeah, if you are supporting iOS 15, you'll probably have to go. There are a lot of open source libraries you can check. I cannot think of their names right now, but there's a lot. Like if you put it in Google, you get like 3 or 4 solutions. I don't know if you can see this, but this is how a module looks, and I will try to explain it for those that can see it. Basically, you have a shared module here, which is Places UI. Basically contain like styles for your buttons and stuff like that. You have a provider, as I said, here you have a bunch of HTTP related code. And one important part is the dependencies here. What we do is we create a simple start that is called dependency registration, and you just pass whatever you have to inject. For our project, we use Factory, which is like a library created by Michael Lunn, that basically allow us to use container approaches for our dependencies. It's very easy to use, and one nice benefit is that when you create a container, you can provide mocks right away. And this is very useful if you are using SwiftUI previews, as we all try to, right, when it works. So basically, when you register your container, you can say, this is the production stuff, and this is the mock stuff, and you can use it directly in your SwiftUI views. Developer experience and tools. One thing that I already mentioned, for us, it was very valuable to use monorepo. It has improved the visibility, the developer experience, the velocity a lot. And again, even though it can sound as a bad idea, a monorepo is not the same as a monolith. It doesn't mean that all code is just tangled up inside. You still have isolation thanks to SPM. And with the new package modifier, you have even more. So right now, you don't have to make a stock public. You can just use package, and it's available to the products of that Swift package, not outside. Continuous integration and continuous development, like everyone. We try to include some caching in there so it can be faster. Catalogs that I'm going to show you right now. And metrics-driven improvements. So basically, before we do some modifications in trying to improve compilation time, we use XC metrics. We get some nice data, and we make decisions based on that. Automate the boring stuff. We use SPM plugins, and we are considering macros. But as you know, macros comes with we did a test, and it increased more than 200% what we were expecting the time to be for compilation. So we decided to wait a little bit to see what the team of Apple does with it. But we use SPM plugins for boring stuff like converting our localization files to a different format. You can use command plugins or preview plugins, for that. And this is a catalog. This is something I took for a talk. I don't remember his name right now. It was from Spotify. Basically, we use Sorcery, and we have this protocol called Catalogable, and what it tells you is just provide me with a title if you want. If not, I just use string, the name of the view. And what we do with this is we look for all the previews that conform to this protocol, and we create this right here. So basically, it'll create a list of all the views you want included in catalog, and you can just navigate, testing, because basically what we do, we create the code that is in the SwiftUI preview, and we put it here, and you can navigate back and forth. And if I go back again, you can see like first you have the list of components, and as you navigate, you can see them. This is done automatically, done using Sorcery. And for us, it was a very nice tool because developers doesn't have to go to look for something. They can just go to the catalog for that package and look what has been done there. So yeah, the conclusion for this. First, at the very beginning, I mentioned we wanted to cover all these, and this is how we got it. Testability, we got it thanks to MVVM and View Inspector. Reusability, thanks to the use of modules. Visibility, catalogs, as I just said, were big for this, and the use of module models too, and modular architecture in general, because you're able to focus on what you need, but you are also able to see what other people is doing. Collaboration, thanks to the monorepo, it helped us a lot. Velocity, a combination of using a monorepo and modules, allow us to develop way faster than we were doing at the beginning. And standardization, also supported by the monorepo, because if you have a Jenkins pipeline, you just have to focus on that repository. You don't have to focus on 10 repositories. And also, you reduce a lot the deployment bundles you have to generate every time you merge a PR, for example. Also, developer experience should be considered when making these kind of decisions regarding architecture. Again, dependency inversion, dependency injection, it's not the same thing, even so they look similar. Catalogs, improve visibility. Keep in mind that having shared models can affect cohesion, so people can just decide to put a lot of stuff into a shared model. We should keep an eye on that. Basically, we trust developers, and we also do every now and then, together with them, architectural reviews to make sure we are not doing anything crazy. Better encapsulation thanks to package modifier. This is something that came out in Swift.9. And basically as I said before, what allows you not to make everything public, you just can use package and it's public inside the package, but not outside. And again, make sure navigation and testing approaches are evaluated early on during your project. Feature packages shouldn't know about other feature packages. Use protocols, use dependency inversion to accomplish this. And last but not least, consider a monorepo. I also wanted to share this with you, and basically is that there are 3 talks that I think are complementary for what I said here today. One is a kind of magic navigation, if you want to know more about navigation, by Stefano. And decoupling dependencies through inversion, which is dependency inversion that I just mentioned, by Michael Baldock, and a blazing fast and consistent generation of mocks. That is David and Sarah will be talking about this tomorrow. Grazie, if you have any questions.